Hello everyone, my name is Nihar Xavier and today I'm going to be going over piecewise functions with you guys. So, what are piecewise functions? Piecewise functions are, believe it or not, they're actually pieces of functions. So, when we think about piecewise functions, we want to think about how we can actually take pieces of the given function and put them and display them on the graph so, our answer makes sense. So, some basic things you guys should know are the transformations of functions. So things like vertical shift, up and down, vertical compression, horizontal shift, horizontal compression, horizontal stretch, things like that. You guys need to be well adept with those things. So now we know what a piecewise function is, so let's get to actually graphing it. So here it says f of x is equal to negative x plus 2 if x is less than or equal to 1. So let's just take a look at this. So it says f of x, so y, another way we can think of it is just y. So y is equal to negative x plus 2 if x is less than or equal to 1. So what we need to do is first take a look at this x is less than or equal to 1 part. So we see this less than sign here. So we know that our circle, or where we start from, has to be filled in like that, okay? So once we know that, we will go to where it is. So let me actually get this thing. So we have to start, so x is less than or equal to 1. So we know that our graph is going to be from here onward, okay? I unfortunately do not know how to make straight lines in this application. So my lines will be a little bit wonky, but that's beside the point. We're going to have to graph negative x plus 2 on here, on this side. So even though negative x plus 2 will go on, it will go in quadrant 1 and quadrant 4, we can't graph it there. So we're just going to have to stop it there. So once we get to actually graphing this, okay, so we see that negative x plus 2, it has no slope, so we can assume that the slope is 1. So actually the slope is negative 1. So we know that it's going to be looking like that. So we can just start graphing it from 1 onward. So we know that it can't go past that 1. So we'll just go ahead and see what the value is when x is equal to 1. We'll see what the y value is when x is equal to 1. So when x is equal to 1, we'll get negative 1 plus 2, so 1. So the y value will be 1 when the x value is 1. So we'll just draw our closed circle here. So now this is really important. Make sure you guys draw your closed circle. I lost many points in my quizzes and unit tests because I did not draw these in. So you guys, this is a really important part of your graph. You guys need to draw this in. So next, because the slope is just negative 1, we're just going to go upwards from there. So we go here, here, there, 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 and then there. Boom, you're done. See? So now we have this part done. So make sure, so another thing is you guys got to make sure that you extend your lines off the graph. So, don't just, end it here and be like, okay, you guys can't do that. You guys got to extend it off the graph. It's just good practice, we know that it's going to be going in that direction, but just extend it off the graph, okay? So next, our second equation is f of x, or y, is equal to 3x minus 2 if x is greater than 1. So now we take a look at this greater than 1. So this greater than 1 means that we're actually going to be going from here this way, right? Because that is the direction which is bigger than 1. So in order for us to do that, we need to take a look at this equation first. So 3x minus 2. So we see that the slope is 3, so we know that this line's going to be steeper than our other line. And it has a y-intercept at negative 2. So one thing I actually do is I like graphing from the y-intercept. So I'll just draw my y-intercept, which is here. and then draw upwards. So our slope is equal to rise over run. So I'll rise 3 and then go over 1. So 1, 2, 3, go over 1. We know our point is here. So we'll draw it like that. Rise 3. 1, 2, 3. We'll go over 1. Our second point is going to be here. Rise 3. 1, 2, 3. Go over 1. So our third and final point is going to be here. So the thing is, x has to be greater than -1. And as you can see, x has to be greater than 1. And as you can see, this area is definitely less than 1. So we can't draw it from there onwards. So we just start from here and then go up. So I think I said that it was here. Yeah. So I drew a point here, I drew a point here, and then we will draw our line. Make sure to extend. That's not extended off the graph. Oh, didn't even go through. Okay, that's good enough. So that is what our final thing is going to look like. So you guys also need to make sure that you guys plot the points, because when you plot points, it's just a lot easier because you just got to draw a line through them. If you don't, you might mess up and you guys might get some weird, line. So you want the lines to be straight, okay? So you guys might have to use a straight edge, but if your teacher doesn't allow a straight edge or something, you guys just draw the straightest line you can. So next, what we want to do is, our next thing is f of -4. So when x is equal to -4, what will y be? So that's what they're asking. So I always make sure to graph my lines before doing these questions because it just helps me to see it visually. So -4. So we just have to go over to x is equal to -4, which would be over here. And then once we go up, that is 6. So we would write 6. Now, the D means domain. So the domain looks like it's going from -infinity to infinity. It's not stopping anywhere. There aren't any asymptotes. So we're just going to write -infinity to infinity. Another thing that that made me lose points when I was taking this course was I actually would put including, so like these brackets instead of the parentheses, and that is a big no-no. Whenever you're talking about something that extends infinitely in both directions, you always want to use parentheses, okay? And then our range looks like it is y is equal to 1. So it would go from 1 onwards. And see, take a look here. Our 1 is actually being included. So we want to use a bracket here. So 1 and then onwards. So the reason why we don't have -infinity to infinity is because the range actually does not extend downwards to infinity. See? This is the limit. It does not go down any further than that. So that's why we don't have our classic, -infinity to infinity. So that's your basic piecewise function. These are pretty easy examples. So let's go on to a little bit more confusing one. So this question is actually just giving us numbers. So there's no real, it is an equation, but there's no, algebraic thing that we have to do here. So our equation here is y is equal to -3 if x is greater than or equal to -5 but less than 0. So we know that our limits are actually going to be from here to here. So our stuff has to be in this range. It has to be in between those two red lines. So our equation is y is equal to -3. So if we were to graph that, we would have to use y. So Vux Hoy. So that would be a horizontal line, okay? So we would go down to -3, 1, 2, 3. And then it says -5x 0. So we're not including 0 here. So So we're not including 0, so we just put a circle. And we are including -5 though, so we will put a filled in circle. And then we've got to connect them because, it's a straight line. So there, boom. Our first part is over. Next is y is equal to 0 if x is also equal to 0. So if you ever see something like this, this is actually a point. So y is equal to 0, that would be this line here, our x-axis. And if x is also equal to 0, so that would be our y-axis. So the thing is, we want to find the intersection between those two, which is just this point. So we're going to fill that in because, it's obviously included. It's not like less than or anything. And then our last one is y is equal to 3 if x is greater than 0 and less than or equal to 5. So what we want to do is we want to go to our y is equal to 3. So 1, 2, 3. This is our y is equal to 3 line. And then we want to go to 5 because that's our upper limit. So we will fill it in because that's being included, And then we will go to 0 because that is not being included. And then we will draw our straight line. So there. You have graphed your equations on this coordinate plane. And these are right because, I'm your tutor. And if I had wrong answers, that'd be pretty embarrassing. But yeah, these are right. And next, we're going to have f of negative 2. So in order for us to not do any mathematical things here, we just got to graph first. But this is, pretty easy anyway. So f of negative 2, so 1, 2, any y's? Yes, we have a y down here. So that would be equal to negative 3. Oops. Next is our domain. So our domain looks like it's from negative 5 to 5. And one thing that you guys need to remember is even though the 0x isn't included, there's this point that's being included. So that will qualify for both of these. So we're actually going from negative 5 all the way to 5. So, not that. We're actually being included. Okay, so that's our domain. And now our range, it doesn't look like we have a set, range of numbers. So we can't just do our regular commas. So we're going to have to do each individual point. So when we talk about individual points in the range, we want to use this curly braces thing, okay? So this will tell us about the individual values. So we will first put this. I'm not really too good at drawing those. Okay. And then our first point is at negative 3. So you want to start from there. You want to go from bottom up. So negative 3, 0, and then 3. And there you go. We have finished our problem about piecewise, and yeah. So let's just do a little bit more confusing one. So this question is slightly more confusing than our other two because our first one was linear and these are also linear. But these two, okay, start from here. Our first two were linear, but this one isn't. So it actually has a square root and a square. So this one is a square root graph and this one is a quadratic graph. So there's actually some operations being done to it, like this 2 and this minus 3. So if you guys aren't up to speed with operations on the graph and like things like vertical shift down, vertical compression, you guys need to go study those ASAP. And you guys got to memorize them for your upcoming quiz or test. So we actually have so let's just start here. So f of x is equal to 2 times the square root of negative x minus 3. So the first thing I see here is not this, but actually this. So x is less than 0. So we know that we're going to be doing something in this range. I'll just color it in. We're going to be doing something in this range. So we're only going to be doing things in quadrant 2 and 3, not quadrant 1 or 4. So when we see this equation, we see that 2 is being multiplied by negative x and then also negative 3. So we know that because there is no horizontal shift, we're not moving anywhere on the x-axis. So we're staying put. We're staying at 0. And this negative 3 is bringing us down 3, right? So the thing I do is I know that a square root graph looks like that, okay? That's not too good. I know that a square root graph, that's even worse. I know that a square root graph goes like that, okay? So if it's down 3, it's going to look like that, okay? And we also see this important thing. There's a negative right here, and because the negative is inside, you're flipping it over the y-axis. So then our final thing is going to look like this. But that's not all. There's more. This 2 is being multiplied to our thing. So we're going to have a vertical stretch of 2. So that just means you multiply the y values by 2. So let's get rid of all those. So we know that it starts from here. So our first value is going to be 1, 2. Because we're multiplying it by 2, right? So usually it would just be 1, 1. Because the square root of 1 is 1. But because we're multiplying the output, which is 1, by 2, we get 2. So it's going to get like stretched upward. It kind of like grew, you know? So we have that. And then our next point would be 2. Actually, no, it would not be 2 because taking the square root of 2 is pretty hard. So what's the next number that we can easily take the square root of? It would be 4, right? So we would go 4 over 1, 2, 3, 4. And 4 squared is 2, right? But we multiply it by 2. So we're going to have to go up 4. So 1, 2, 3, 4. This is our next point. And then we will again just connect. And now our next point would be 9. But because that doesn't really show up here, I would just follow the general trend, you know? I would just say, okay, I'm just going to keep it going like that. So don't do anything crazy, okay? So like, if you were going like this, don't be like, you know, I'm just going to go like, no. Just always make sure to follow the trend, okay? Follow the trend that you're going in. You want to make it nice and, that's linear. You want to make it nice and fluid, okay? There you go. So now we have our first one down. And that satisfies all of them. So our next one is y is equal to x squared minus 1. If x is greater than or equal to 0, but less than or equal to 2. So our interval is going to be in between 0 and 2, and both of them are being included. Yeah, both of them are being included. So what you're going to want to do is, wait. Oh, okay, wait. Do you guys realize that there's actually a mistake in what I just did? Believe it or not, there is. Because if you take a look here, this is x is less than 0, right? So we're not including it. We can't include that. Oh, whoops. My bad, y'all. This is unacceptable. Your very own tutor messing up on a question. What the heck? Erase. I'm gonna have to cut this out. See, even your own tutor is susceptible to confusing questions in Algebra 2. So we want to have a circle there. Alright, so now that that's fixed, we will have x squared minus 1, and then in between those two things. So what we want to do is, this is actually a quadratic equation. So it's going to look something like this, right? That's actually a really bad thing. I did not draw that properly. So a regular quadratic would look like it would look something along the lines of that. But we are bringing it down 1. So we have to start from here. So because there's a vertical shift down, we will start from here. And remember, it's being included at the 0. So yes, I should draw my filled in circle. Next, we will just go 1, 1. 1 squared is 1. We'll draw that there. And then we go over 1, 2. 2 squared is 4. So 1, 2, 3, 4. Guys, it is extremely important you guys don't go and fill in 4, okay? Because we are counting up 4. We are not talking about the physical 4, okay? So we're gonna go like that. And see, the reason I filled it in here is because this 2 is being included. See? The 2 is being included. So yeah, that's that. That is your final graph of your piecewise function for this question. So what we're going to do is f of 0, right? So let's just take a look at what 0 is. 0 is -1 because we see this -1 here. It would not be -3 because it's not being included here, right? It's not being included. That's an empty circle. So -1. Now our domain, we know this extends on for infinity over this way. So we know it's going to be -infinity something. So if we think about it, we bring that -infinity back all the way here. Uh-oh, it's empty here. It's empty at the 0. But this actually is filled in. It's compensated for by this. So this is actually being included. So your equation is never breaking. You'll always have a y value for each x value. And you come up all the way until 2. And 2 is being included, right? So we'll draw a bracket. And the range, it seems like, this is our lowest point, right? 3. Seemingly, it's our lowest point. But it's not actually, because we're not including 3. So we'll have a -3. And then it goes on for infinity because of this equation. Not negative. Okay, so this is our final filled in thing. Alright, one more question, and then you guys can be confident that you are prepared for piecewise functions. So they will sometimes ask you to write a piecewise function for the given graph. So you kind of have to, work backwards in the math. So one thing that really helps me is just to start out by drawing f of x. So now that I've written that, I can actually just draw out this entire thing. And now, I'm kind of cramped here. It's fine though. So now I know I have to take a look at my intervals. So we have an interval that is from -infinity to 0, right? This part. So one way we can write that is, so we don't know what the equation is yet. So we'll just put in a comma there, and then we'll add if x is less than or equal to 0, right? Because that's what's happening here. It's less than or equal to because it's filled in here, so it's less than or equal to 0, right? So now our equation, it's just a straight line, so it's pretty straightforward. We know that it's a y equals equation, so 1. Okay? Now our next thing would be this 2. So again, I'm going to start with my interval, my piece of the function. If x is greater than 0, right? Because it's not greater than or equal to, it's just greater than. So now that we have that, we see that it's at 2, so 2. And then our next one is actually at 4. So we know that it's at 4, so we can just write that in. 4 if x is greater than 5. So the reason why it's just this, it's just greater, it's not greater than, is because, again, this is empty, right? So there you go. You have written it out. So that's that. They usually won't ask you for any crazy equations, like, 2 square root of x minus 2. They usually won't ask you to write equations like that. They'll usually be linear or just these, simple y equals equations. So thank you for listening. I hope you understood what piecewise functions are and how to do them. And yeah, I hope you guys do good on whatever quiz or test you guys are studying for.